Thank you. So welcome everybody to the Astro Cafe for February the 5th, 2024. This is the first and last Astro Cafe for February because of the AGM and then the Family Day and then the social. So we'll try to make this a good one. Got a few people that want to speak today. Is there anybody else that wants or has anything to present that you want me to put on the list for coming up?
So Jeff, I'll speak to the social event about the location and what we found on Friday, and maybe answer any questions that people might have. And also, I want to talk briefly about SIGs this week.
Okay. You want to do that then? I'll put you in right after you speak to the social about the SIGs then.
Yeah, good, that's fine.
Super, good.
Nobody showed any photos last week. We need photos.
Oh, I'm hoping is Malcolm on the call here yet? Okay.
I don't see him yet.
Is Chris Gaynor on the call? Because there's been some interesting stuff coming from the James Webb telescope.
I don't see Chris yet.
Okay.
We need weather to get photos.
Oh, that just means that you can't, you don't have time to process if there's good weather.
Well, I think Ken McGill offered to tell us about his use of NASA base images. I don't know if he's ready tonight, but he was going to do something for us with respect to that. We don't need good weather for that.
Ken,
Yeah, I was going to go through the astronomy SIG.
Okay.
One, then I'll do it after that.
Okay. Sounds good.
Okay. So I have a little presentation that I wanted to talk to you about today. So I'm going to just do a screen share and then I'll start that. So this was actually originally inspired by David Payne, who had one of the astronomy pictures of the day, the APOD. So I was trying to think about what was going on today, and I was glancing through the APODs, and the picture of a moon of Saturn, Enceladus, came up as the APOD from a year ago. So I started reading about Enceladus, and it really is a very interesting story, and it kind of wanders through some of the people we've spoken about before, and goes back to some of the astronomy in the 18th century. So it makes an interesting story. I'll try to stay with the main storyline, but there's a couple of little eddies that come up. I think some of you here are going to know a lot more about this than I do. So if there's additions, please feel free, or if there's comments afterwards, please chime in, because it's really an interesting area. So Enceladus. Enceladus is one of the smaller moons of Saturn. It was, let me just get rid of this. It was first discovered by our friend William Herschel in August of 1789. It was probably, they're not sure which scope he used, but probably it was discovered when he was using his new reflector, which he made when he moved from Bath to his new location in Slough. We'll come to that in a sec. The name Enceladus actually came from his son John a number of years after he first discovered it. And I was curious as to why John called it, Enceladus seemed pretty obscure. But actually, for an 18th century mind, it was actually brilliant. Saturn was originally called Cronus by the Greeks. Cronus was the head of the Titans. The Titans were the monsters or the giants that came before the gods on Olympus. It wasn't a really friendly relationship. The Titans attacked the gods on Olympus and were defeated. So he reasoned that all of the moons of Saturn or of Cronus should be named for the Titans. So in fact, Enceladus is one of the Titans in mythology. Enceladus was the Titan that attacked Athena and was killed by Athena. Depending on who you read, it was killed by either her armor, a stone, or a spear. But anyway, back in mythology, he fell from the sky, and he was buried in Sicily under Mount Etna. So the name Cronus seeded the name of the moons of Saturn, and we get Enceladus from that. So back to William for a minute. We all know of William discovering Uranus. He discovered Uranus in 1781 in the beautiful back garden of his place in Bath. He used a 6.2-inch reflector at that time. Lovely scope, kind of bucolic thinking. But he and Carolyn moved in about 1785 to a much larger place close to Windsor. And he built over 3 years a gigantic reflector, which was called the Great 40 to all astronomers of the time. And it was called the Great 40 because the convention then was to name telescopes by their length rather than the objective mirror or the objective lens. So anyway, Great 40 had was a 48-inch reflector. And that's where he started doing some of his observing after, I believe, 1788. The interesting thing about this scope is it was designed by him, and it was a different type of reflector than any others. This was called a Herschelian reflector. One of the problems at the time was that the secondary mirrors that reflected light were really easily tarnished. So instead of putting a secondary mirror in, he angled the primary mirror so that it could focus. He could look down the barrel at the focus. So from the side, and it's in the design, you can see the platform that he could stand on. He could climb up and look down the primary mirror to see the image. It suffered its own problems. 40-inch mirror. Originally with the casting, the first one was too thin and bent. Second casting cracked, so it was the third casting that resulted in the mirror that he used. The mirror was an alt-azimuth. It was it could be rotated on its base. It was actually the largest scope in the world for 50 years after it was built. So the speculation, but it's not confirmed, is that he discovered both Enceladus, the 6th largest, and Mimas, the 7th largest moon of Saturn, within about a month of each other in 1789. So we didn't know a whole lot about Enceladus after that. It was sort of a small moon of Saturn, the 6th largest. And it wasn't until the flybys of the Voyagers in 80 and 81 that we knew anything further about it. It's got a very high albedo. It's very reflective of light. It's thought to be an accretion of icy particles and gases, and one of the most reflective bodies in the solar system. But beyond that, it still was sort of put aside as an icy moon, of frozen water, and nothing else was really thought of it. And that was until about 2004, when the spacecraft Cassini went into orbit around Saturn. Cassini had gone up to study Saturn, the rings, and also the moons. And that's when they started finding some pretty amazing things about Enceladus. So they got some really interesting pictures, and it still looks like a ball of ice, but cratered. But with some of the close approaches, they started seeing some really interesting things. Firstly, the magnometer saw some disruptions in Saturn's magnetic field close to Enceladus, suggesting that there was actually some geologic activity going on, which they attributed either to escaping gas or an atmosphere. or possibly a little wobble in the orbit itself. But we'll come to that in a second. They did some further passes over Enceladus with Cassini because they were able to direct it. And it showed some really deep fissures in the south pole of Cassini, which they called tiger stripes. And these seem to be overlying hotspots in the south pole. And I'll show you some of the infrared that they did. What they found, there were jets coming out of the fissures, and they actually flew Cassini through the jets, and they found it was made up of both water and some organic chemicals. They found the jets were spewing hundreds of miles into space and either falling back onto Enceladus as snow or escaping the very weak gravity of Enceladus to form what became the E-ring of Saturn. And I'll show you a picture of that in a moment. They did discover the wobble in Enceladus's orbit, and it suggested that the icy crust wasn't really solid, and there was an underlying ocean of liquid water. So Enceladus is one of the smaller moons of Saturn, 99% reflective, and to demonstrate the importance of that, the albedo of Earth is about 30% and Venus about 70%, but nothing else comes close to the 99% of Enceladus. This is a picture they got from Cassini of some of the jets coming off the South Pole, the jets that they flew through. So even more interesting, when they flew through it, they actually had some spectrometer readings and saw that it was both water, ammonia, methane, carbon dioxide, nitrogen gas, traces of oxygen, and silica. The silica was really interesting because the only place silica could come from is if the jets were coming out from heating of geothermal vents in a rocky core of the planet. I'm sorry, of the moon. So, given that there's deep in moons that are beyond the frost line in the solar system, there's only a couple of ways you can get heating. One of them would be from radiation, but the core of Cassini would just be too small to be heating and to be continuously heating ice to stay in liquid form. So it really seemed like the geothermal vents were likely, and the heat from the geothermal vent would be because of tidal warming, because Enceladus has a not around orbit, a somewhat oblong orbit around Saturn. And they found that that was due to a resonance that Enceladus has with a further out moon called Dione, also orbiting Saturn. So you have a maintained elliptical orbit of Enceladus generating heat. The heat is creating the geothermal vents, and that's keeping the water and other volatiles in liquid form.
Jeff,
Yeah,
you know what the frost line is?
the frost line is the line in the solar system or in any beyond any sun beyond which the volatiles can't exist in a liquid form. So in our solar system, the frost line is just around the asteroids. So the Jovian planets are beyond the frost line, and the more rocky planets are inside the frost line.
Huh. Does
that answer the question?
Yeah, I mean, I have other questions with it, but I'll have to look them up. It's really fascinating.
This was a really, and this also is from Cassini, showing an infrared scan of Enceladus and just showing how warm this is of the South Pole, how warm the South Pole is. I didn't show you the other 6 red scans, but they're blue, from the sides and the top. So it really is the southern part that's warm, and that's where the liquid's coming from. So the thing that then struck me, I mean, there's a whole bunch of questions that come up, but I didn't really understand why they called the spacecraft the Cassini spacecraft. So the Cassini SIGs, because I didn't really know about Cassini. So Cassini, it turns out, is a French-Italian astronomer who, of course, was the one who identified the gap between the A and B ring of Saturn, which is called the Cassini division. But that, in fact, also seeded a problem and a mystery that was only solved in 2013, and I'll come to that. So Cassini was Italian by birth. He worked in Bologna, Italy, looking at Jupiter, Jupiter's moons, and Mars. In 1669, he was invited to Paris, France, to become the director of the Paris Observatory there. And among other things, in the Paris Observatory, he identified 4 moons of Saturn and also calculated the Earth to Sun distance. But he's still best well known for identifying the Cassini division, which is about a 3,000-mile gap between Saturn's A and B rings. We all have seen the Cassini gap. It's really obvious in any real photo or any good telescope photo of Saturn. This is just from Zenfolio that I found. This is Andrea Geron's picture of Saturn, and you can see the dark line right here. And I'll give you a better picture of Saturn so you can see what the rings are. But this is a dark line you can see, and she's helpfully labeled Enceladus and Dion also, which is the moon that's that has a resonance with Enceladus's and maintains Enceladus's elliptical orbit. So this is just a stock photo from Adobe. You can see the Cassini ring even better. And this is a photo from Cassini, and you can certainly see the Cassini ring here. Interesting. This is a sort of a diagram of the rings, so you can have the significance. The rings of Saturn are named in order of discovery. So the largest outermost ring is the A ring. Inside that is the B ring, and the Cassini division is between the A and B. You then go C and D inside. Then you have this huge ring here, which is the E ring, which is the spewing ice from Enceladus. And then there's been some other small rings, F and G rings, found since that. They're kind of on the outside of the A ring, but they're divisions because they found small divisions further out in the rings. So as I said, the controversy about the Cassini division and the discovery of the Cassini division was finally resolved in 2013. But to understand that, you have to understand what the problems were with observing through telescopes at that time. And the biggest problem they had with the refractor telescopes was chromatic aberration. Chromatic aberration is the problem with focusing the wavelengths of light in the same place. In fact, they don't focus in the same place, and it leads to a blurry image. The way they resolved that in the 18th century was to use very, very, very long tubes. So they were able to get very long focal lengths, but they had very small objective lenses on those. So just to illustrate chromatic aberration, light doesn't refract perfectly. So the more energetic blue type wavelengths refract more, and the longer, less energetic wavelengths reflect at a further distance. So the way you deal with that is you make them refract over a very long distance, so there's less separation between the wavelengths. So they had some just enormous telescopes. This is a woodcut. I don't think this is of a real scope, but they had some enormously long scopes that were just very long tubes that were very, very difficult to manipulate. So this quote, dealing with chromatic aberration could result in extremely long telescopes, notably in the 17th century. One of the telescopes was 36 feet long with a 34-foot focal length lens, while other lenses in the arsenal had focal lengths up to 155 feet. just enormous telescopes, and they were very difficult to manipulate. And you can imagine assistants running around the outside, trying to rotate it, trying to stabilize it. And in fact, we know the scope that Cassini used. He used it to identify the what became the Cassini division with a refractor that had a 2.5-inch objective lens with a 20-foot focal length, giving a 90-time magnification. Of importance, in his letter to the Royal Society in 76, he described Saturn's rings as being divided by a dark line. So here's the problem. At the closest approach, Saturn is about 750 million miles from Earth. And the angular size of the Cassini division at that distance is about 0.65 inches of arc. Sorry, seconds of arc. That's about 2,700 times smaller than the moon. But if you do the calculation with his scope, the resolving power of his scope, if you just do it, if you just plug it into the formula, it's about 1.8 seconds that he can resolve. And if you do it through a calculator, making the assumption that the light is only 400 nanometers, which is just the red end of the, the blue end of the spectrum, it still gives him about a 1.6 second distribution resolution. So seemingly the resolution of his scope would have been not fine enough to actually see the Cassini ring or the Cassini division. This became, in the one-upmanship, this became a real matter of concern for the Paris Observatory. And, you wonder how they could possibly resolve that. Well, there is a way. There is a Society of Photo-Optical Instrumentation Engineers, or SPI, an international organization, not for profit, for studies in optics and photomics. It was first founded in 1955. The Paris Observatory requested that they do some studies there, and it was Dr. Losey and some other colleagues belonging to SPI who looked into it, and they really pulled it apart. They tested the quality of the lenses that Cassini used. They simulated where the planets would be. They simulated what they speculated was the atmospheric condition around the time he was looking, and they published their findings in 2013 in the Proceedings of SPI. Fortunately, that was also published in an open journal archive. And the findings were the conditions were almost optimal. The rings were almost at maximal inclination, and the vision had a maximum size. And Dr. Losey, who was in charge, said, and there was also no street lighting. Cassini's drawings don't show a very clear line, but only a difference in color between the main rings. So his final conclusion was, taking into account the chromacity of the glass, the wavefront quality, and the atmospheric turbulence, reconstructions of that is Cassini's observations, tend to show that he was actually able to see the division that was named after him. So that gave qualified approval of the finding and really confirmed that he was responsible for discovering the Cassini division that was named after him. So that was put to rest in 2013. We have much better images now of the Cassini division, and this is from Cassini. Interesting. This is interesting. It's almost an optic illusion. This is shot below the ring, below the plane of the ring, not above the plane. I see this as on top of the plane, and sort of I have to think hard to see this shooting from the bottom. But it also shows the moon Mimas in the same frame. And what they found was Mimas is in a 2-to-1 resonance with the Cassini division. And they feel that it's Cassini, this is a Mimas orbit, which is both pulling and pushing the contents of the Cassini division and maintaining it as a relatively unpopulated area of the rings of Saturn. So just once more, the rings, you have the Cassini division between the A and B ring, And you have the E ring, which is the large amount of gas in ice form that's spewed out from Enceladus. So we now know Enceladus is about 14% liquid water. It's very small. It's got a diameter of 504 kilometers. It's about 9.5 astronomical units from the sun. Orbits Saturn in a blindingly fast sort of 33 hours. Surface temperature of minus 201 degrees centigrade, and it's in tidal lock with Saturn. So the same face is always towards Saturn. And you can see this is sort of shot of the South Pole, and you can see what they call the tiger stripes, which are these fissures. So just last slide, just a comparison of the larger moons of Saturn. As you know, there's over 100 moons now of Saturn. There's some just tiny ones, but this shows the Earth's moon, Titan, which is the largest moon, and Enceladus is here, the 6th largest moon. So that's it. Happy to entertain comments or other thoughts.
One thing, just to go back, that's a lovely presentation, Jeff, I must say. Just a little bit of the mythology around it. You said that he was buried, Enceladus was buried underneath Mount Etna. Apparently he wasn't dead, but he was buried there under this enormous lump. And the fury of Etna is him struggling to escape. That's the way the Greeks had it. All this fire and spume and earthquakes is him struggling to get out still. Giants were really giants in those days.
Interesting.
I have to share a picture. Because my favorite fountain in the gardens behind Versailles is the Enceladus Grove, and that's like, it's just this crazy big fountain, and when you look at it closer, there is poor Enceladus being buried by the rocks.
Huh.
Absolutely fantastic.
And where is that, Randy?
In Paris, well, just outside Paris,
Interesting.
Versailles.
the Chateau de Versailles.
So from anybody who's doing real astrophotography, I mean, they do make a big deal about Enceladus being, so bright. Is Enceladus a target at all, or is it just too small to really be anything that you can appreciate?
Well, it is pretty tiny. I think of interest as probably just its position with respect to the planet. You're not going to see any detail. It's very small.
Do you get a bright dot?
I don't know if I've ever captured Enceladus. I mean, Titan for sure. I mean, Titan's really common to see in images. I'm not sure about Enceladus. Brock, you've done some imaging of Saturn. I can't hear you.
Sorry, I've never tried for the moons in any great detail, just because I've usually just tried to get Saturn's disk, and it's often a bit of a trade-off. You get one, or you have to go after the other, and you blow out Saturn itself.
Yeah, for those people who are not planetary photographers, typically the moons are one exposure and then the planet is a different, because the moons are quite dim by comparison. So if I was to do it, I'd probably do a comp. I'd do an exposure for the moons and then do my best at getting a kind of a stacked image of the planet face.
Yeah, amateurs usually capture the 4 largest moons of Saturn, but Enceladus is bright, but not very big.
Okay. Yeah, no, it's a pretty huge distance. I mean, to get kind of resolution like the Cassini craft, they were quite a bit closer than we are.
It's quite interesting, the fact that he had such a small aperture telescope and was able to see it. I mean, in my small refractors, I need really good seeing, and it does come and go. I can for sure see it, but if the seeing conditions are not good, you won't. It's
Mhm.
just on the edge on a small scope.
Just on the liquid water thing. Water is a bit weird in that it expands when it freezes. And if it's under sufficient pressure, it can exist as a liquid. So if you have it buried under ice, and that ice, so you have ice for a while, once the pressure, depending on the temperature, of course, once that pressure can overcome the freezing. I don't know what my critical pressure and what critical temperature would exist at such low temperatures. But that can keep the water liquid.
That's a really interesting point, and I hadn't thought about that. The other thing they commented on was the presence of ammonia, which has a freezing point about 100 degrees Fahrenheit below water, may also be part of what's maintaining it as in a liquid phase.
Yeah.
The pressure is an interesting thought. What we don't know is how much, I mean, it's obviously venting, but whether that, relieves pressure. There's also some thinking that depending on where in the orbit of Enceladus it is, the fissures may open and close. So you get venting in some places and not in others.
Right.
Okay, well,
Before you go on, Jeff,
yeah,
first of all, I really enjoyed your talk about the moon. When Linda Spilker was in Victoria at UVic, she gave a talk, and she was the project scientist for Cassini, and she expressed to me her chagrin that when they flew through one of the plumes, there was some concern that they had not totally sterilized the spacecraft. So it was possible that they might have contaminated the plume with some of the stowaway germs that were on the spacecraft. So maybe they colonized Enceladus that way. And the other thing is that one of the things that Cassini did was that he very accurately measured the orbits and times of the moons orbiting Jupiter, and his measurements were used decades later by Romer to calculate the first estimate of the speed of light. So cool. It's kind of neat.
it is interesting.
They were also used before they had accurate chronometers to try and get longitude for people on boats. If you check the times of the orbits of Jupiter appearing and disappearing at different points on the Earth, you had tables and catalogs, books of where they should be at this time if you're where you are on the Earth. And those were used before they had chronometers. But the mathematics involved, well, those guys were good considering they had only their heads to use.
Interesting. Yeah, any other thoughts or comments?
Hi, it's Kirsten. I just one thing I just thought of, just talking about the issue of biological contamination. One thing I know that was a real concern to the Cassini project scientists was the potential crashing of Cassini when it was finally running out of fuel, and they were very concerned actually that it could crash into Enceladus. And from their perspective, that would be a worst case scenario because biological contamination being a real risk. So that was the biggest reason why they wanted to fly, directly control and fly the Cassini probe into the atmosphere of Saturn to ensure its destruction. I thought it was just an interesting point.
It is an interesting point. Yeah. a lot of attention paid to that. Randy, did you want to speak to the AGM?
Well, I'll do that after I do a presentation, if that's okay.
Why don't you do your presentation then?
Okay, so share. And I just want to start with going on what Oliver just said about using the moons of Jupiter for timing. I just yesterday finished setting up my new mount that I bought from Reg at the buy-in sale in November on the telescope that I got from Sid. And yesterday I took these two pictures not an hour apart, and you can see Io coming in towards Jupiter. But it does bring up a point. It would have been very hard to actually time with my 6-inch telescope the actual moment that of occultation. That's a really interesting thing. How fancy a piece of equipment. This is like what Jeff was talking about with Cassini. What could he actually see with his optics? What would it take being on a ship? So it's not even a stable platform to actually time when the occultation, when the moon hits Jupiter. That would have been really tough. But this was the first time that I have seen how fast Io is going around Jupiter. I was very pleased with that.
Mhm.
Okay, but that's not what I want to talk about. What I want to talk about is Bill here. Oh, excellent. You're here, Bill. So Bill gave that wonderful talk last week about Zoozve. And I couldn't but get down that rabbit hole because it was so wonderful. I listened to Radio Lab that night, and it's a great show. I highly, highly recommend. And Bill sent out the link to it to everybody. And this fellow, Latif Nasser, who went to school here. And did you actually know him, Bill?
No.
Oh, okay.
Although I may have met him last summer and not known it. Because he would have been at the reunion, one of the reunions that I did the observatory tours with. But it's in the dark and there's lots of people. And so he may or may not have been up there.
Anyway, this is very clearly a kid's poster. And yet it very clearly has Zoozve as a moon of Venus. And he was quite right to pursue it. Anyway, it does have a delicious story. So if you go to the JPL website, there it is. It actually in perihelion is closer to the sun than Mercury, and at aphelion it's further away than the Earth. It is not a moon of Venus, okay, by any stretch of the imagination, but it has the same period going around the sun as Venus. So let me click on this. Are you going to do this? You can do it. Good. And then we go down here and I hit play, and we'll just watch this for a few decades. Okay, so you see purple, that's Venus, and 2002 VE68 is now, it's a bit behind, but it comes in close to the sun and it goes ahead of Venus. Good. But now Venus is inside and Zoozve is going slow and it gets behind. But you see, every once in a while, it actually gets pretty close to the Earth. It's about every 8 years. And, you know, look at that. Look how close they are to the Earth. Okay, so back to the presentation. I better stop this or it'll just keep going behind.
Close in projection, but not necessarily in space.
So this is what it looks like. If you hold Venus at one longitude, so you can see the green dot is going in and out. That's between perihelion and aphelion. And the orbit of Zoozve is going back and forth, but never very close. But it definitely is, it's called a quasi-moon. It's a quasi-moon of Venus. And the name is official as of today. Thank you, Peter. How exciting. Hot news, right from our asteroid specialist. That's super. Anyway, here are the 3 types of co-orbital configurations. So there are 3 ways for a small body in a 3-body system to have the same period on average as the second body, in this case Venus. You can have a tadpole centered. Look, do you see how that's an equilateral triangle, 60-degree triangle? And that is because there's Lagrange points 60 degrees ahead and 60 degrees behind where you can orbit around. Okay, those are stable orbit areas or quasi-stable. Then there's this crazy thing called the horseshoe where it goes back and forth, which just seemed bizarre to me. But that really is going around another Lagrange point, which is on the antipode, the opposite side of the sun from where the planet is. And then the third one is around the planet itself. And then it gets to be called a quasi-moon, or in this case, a quasi-satellite in this figure. Okay, so this is just a way of seeing how the gravitational potential plus the centrifugal force leads to these Lagrange points. We've heard about L1, where they put spaceships that are supposed to check the solar wind before it hits the Earth. And L2, famous for Gaia and Webb and I don't know what else, but there's quite a few that are parked out there. But around Jupiter, so that's supposed to be Jupiter, there's oodles of asteroids. Oh, can we get rid of the that bottom line? Our presentation here in the room, we got to do some trick to get rid of the.
You got to read the chat message.
Yeah, go
in more.
Go to the more. Click, no, there. Yeah, click on that.
And click on chat, and then close it again. And close and exit it.
There we go. Thank you.
Now it will go away in a moment.
So it's kind of cute. They're called Greeks when they're going ahead of Jupiter, and they're called Trojans when they're lagging behind. But these are stable places. So there are these different sorts of co-orbital, what was the word? Configurations, thank you. And right now, Zoozve is going around the planet itself. And so 2 years after its discovery, there's this paper where they worked out the orbit. And on the Radio Lab show, you can hear Serpo, Mikola, and is it Paul Wiegert. Peter can tell us. Paul, Peter. Anyway, they were both.
Yes, Paul is a London Center member.
And they're excellent. They're very good interviews. I just love them. Anyway, crazy difficult work because they have to. This particular asteroid comes so close to Earth that you have to include the moon in the calculations, because when it comes close to the Earth, the gravity of the moon also affects it. And so they did a digital calculation of where this asteroid has been in, they calculated for 10 times a day. Okay, so they just say this is where everything is now and how fast they're moving, and then they go a tenth of a day and figure out where it's going to be, and they keep doing that over and over again. And you do that and you see that L4, the fourth Lagrange point, is where it was until, I mean, we don't know what happened before that, but 7,000 years ago, it dropped from L4 to being a quasi-moon or a quasi-satellite. And then in only 500 years, if you hold your breath, it's going to happen. It's going to go to L5. It's going to move 60 degrees along. And then it's going to go around the back to L3. And it doesn't all of a sudden do a great big shift. That's just, you know, it's going from minus 180 to plus 180 degrees. So same position, right? Just going around the back of the sun. And then it's going to go up to L4. And, you know, it's kind of chaotic and they don't know what's going to happen after that. And, you know, because they have to look at all the different bodies. And it probably was, it got too close to the Earth once and that swung it around towards Venus. And so, yeah, it only comes close to the Earth about every 8 years. And so in 2010, Barrias and a few other authors did some detailed photometry of it, and they could see that it's not, you know, this was 3 nights in a row, and they could see that it was flipping around. And from this, they could work out that it was very elongated. It might even be a contact binary. It might be a couple of asteroids that are just kissing each other. And it's going around, you know, like twice a day. And from some measurement of its composition, they could figure out what its albedo is. And from that, they could figure out how big it was. Just amazing work. Okay, so a lot of the Radiolab show was about naming the asteroid. And he talks a lot about the working group small body nomenclature. And if you go there, there is their 20-page guide on naming asteroids. And it's a great read. It's just delightful. I've just pulled out a couple of things. Let me read this out loud. Small bodies can be named by their discoverers once their orbits are sufficiently well known and small body numbers have been assigned by the Minor Planet Center. So in 2002, they couldn't have named it. It was just given the provisional name 2002 VE68. But after 2004, when they worked out the orbit, then they could have named it, except this was part of a survey that was finding hundreds of these asteroids every month. So it just got forgotten. Small bodies are uniquely identified by their provisional designations assigned at discovery and later by their Minor Planet Center number designation. The addition of a name to a newly numbered small body is not required for identification. So this whole thing of naming things, Enceladus or Eros or whatever, that's not necessary. It's just for fun. However, names have traditionally been assigned to many small bodies and have drawn from mythological characters, planetary scientists, astronomers, and accomplished scientists, engineers, and technicians in other fields. People who have made contributions to the arts, sports, medicine, and other aspects of society are also recognized. discoverers have also used names of personal significance to them. And that's the important line for what's going to happen. So, Latif Nasser thought this was such a great story that they should name it and name it as the artist, what's his name? Alex Foster, yeah. Drew, because it's of special significance. It was on his 2-year-old's poster. Anyway, you have to say it in 360 characters. Or fewer characters if they have diacritical marks. They define everything in this 20-page document. As the first quasi-moon ever discovered in the universe, this object deserves a name as rare as its orbit. When artist Alex Foster drew this object on a solar system poster for kids, he misread the temporary name 2002 VE as Zoozve, thus coining this original, odd, and memorable name.
I like that.
Anyway, so Latif sent this to the discoverer, Brian Skiff, who then sent it to the working group small body nomenclature. And the other thing that Bill suggests is that we listen to the actual astronomy podcast where our own Peter Jedicke is interviewed, and he talks about them a lot. But they, Peter's now got it to an art, and he's done very well getting the people nominated from all the RASC centers in as names, like Chris is here somewhere. Chris has one. And Laurie online here, and Sid, who I don't see here now.
Sid.
Anyway, so this is very much because Peter sent these 360 character submissions to the WGSBN. Now, the problem is section 4. And I'm not going to read this all out, but you'll see that for near-Earth asteroids, okay, so that are within 1 1/8 astronomical units, so, pretty close or inside of the Earth, they have to be given mythological names, except those associated with creation or the underworld. Why? Creation mythological names are for trans-Neptune objects. That's at the bottom. And the underworld is reserved for the Plutinos. And Plutinos are the ones that are around Pluto's orbit. And an Amor, by the way, those are the ones between Mars and Earth. But the ones that are further distant can be named anything. It's the ones that come close to the Earth have to be mythological. And part of the thing is they don't want to have somebody's name attached to an asteroid that comes and destroys all life on Earth. That would be bad PR.
Damn.
Only briefly, though.
Yeah.
Anyway, so there's a poster in all its glory, and with Zoozve there, and that's the story that was in Radiolab. And thank you, Bill, for bringing it to our attention. I really enjoyed doing a deeper dive.
Thank you. That's really good.
I believe the poster is still available for sale, so you can
I
order
bet
it
he's going to
from.
sell a lot of them now.
They are sold in British pounds, so yes. I'm from the UK.
Thank you, Randy, for that.
If there are no questions, we'll go on talking about the AGM, but
I have a question.
you do.
You said it was calculated as being last near the Earth in 2010.
Oh,
Talk a little
no,
bit louder.
there's been enough. The question is, when has it been close to the Earth? And
When's the next going to be?
I don't know if it's perfectly periodic because it's got a pretty crazy orbit. But I know it was in 2002, 2010. So I wouldn't be surprised if it's happened a couple of times since then. Certainly the JPL site, you could you can look at that. But in 2014, they that article that figured out that it was elongated, they also reworked out the orbit, and they totally agreed with the preliminary one that it was captured about 7,000 years ago. And it wasn't going to stay long. But I didn't go check that. And it will not come close to the Earth. It will not come, you know, even within a lunar distance. It's going to be something like 10 times as far as the moon at its very closest over that whole 7,000 years that it's a quasi-satellite. So we don't have to worry about it. Okay, next Monday, don't come here. You are not going to see it open. We are going to hold our annual general meeting on Zoom. It will not be the normal Astronomy Cafe link. There's a special link so that Chris can set up the votes that we're going to need. And what are we going to do? There will be an annual report, which I still haven't written. And if people want to put things into it, activities that we have done this year, do write me emails. I've been getting lots of emails, and thank you to everybody who has contributed. And I'm sure there are a few more of you who can say, don't forget that we did this, or don't, please know that I did that.
Randy, could you send around a interim version of it so we can, because I'm better at seeing if something's missing as opposed to
that
adding
assumes
things.
that I'm going to write it ahead. Okay.
Well, no, you can go back and look at all the past ones on our website. In the members only area.
Oh,
The
thank
reports
you.
are all there.
Thank you.
Just pick last year's or the year before and have a
Yep,
look.
that's good. Good suggestion.
Okay, did you understand that, everybody? If you have things to contribute, you can take a look at what last year, the year before, by looking in the members section of our website, victoria.rasc.ca.
And they're published by the National as well, of course.
Right. Okay. And an important thing about our outreach activities is our tax-free status is based on the fact that we are providing education to the citizens of Canada, and they are supporting that by giving us tax-free status. So we do have to prove that we're doing a good job in our mandate of outreach. Okay, so that's the one thing. Then we will have, very important, our financial report. And, you know, spoiler alert, we haven't spent all our money, so we should figure out more ways to spend money. There's going to be an election. And why don't I give the floor to our, what's it called? Our election subcommittee?
Nomination committee.
Nomination committee.
Okay. Hello, good people. It is with my great heartfelt thanks that I want to thank Chris Gaynor for agreeing to stand up and run as president of RASC Victoria Center for the year 2024. So I was immensely happy about this, and I slept a lot better after Chris agreed to do that. So for myself, at any rate, I'm very thankful.
Will Chris be the first person to come back for a second term?
No, about the third or fourth, I think, actually.
Oh,
that hasn't been one too recently, though. I think Jack Newton was president twice.
But I
think the most recent.
I think you'll be the only national president.
Yes.
That's also a center president. Our center president, anyway.
But I've already done both of them.
I
so.
know.
Well, I was gonna try and talk Peter Jedicke into being president, but I didn't think he'd go for it. And,
Peter was also a national
he was
president.
also a national president. But yes, I'm happy to be here today. You know, I used to be the person who lived closest to this place where this Astro Cafe takes place, and then unfortunately 10 years ago, I became one of the farthest away from this place, but I happen to be in town today.
Oh, good.
So here I am. I'm not going to be able to make too many of these, but I'll make them occasionally. But I'll be at the monthly meetings, and yes, the last time I was president of Victoria Center was 20 years ago, and I've been sort of pondering that, you know, all the changes that have taken place since then. I'll speak about that, you know, once I'm president.
Okay, is there anything else you want to say?
Well, we do have a full slate of people who are standing for office. So the positions are president, vice president, second vice president, secretary, treasurer, and then 5 directors at large. And they comprise, and also the past president, as they comprise 11 people who found or make up our, I guess, our executive of our council for our society. And we reduced the numbers greatly through the kindness of Jill Sink, we revised our bylaws last year to enable us to get a smaller group so we could more easily get a quorum to make decisions and stuff like that. But we still have a number of positions, our jobs that we encourage active people to stand up and perform. And those positions will be kind of assigned at the next council meeting after we have our new council in position. But don't watch out. You might be getting a phone call for me to kind of encourage you to stand for a particular position, or give you a tremendous number of opportunities where you can deepen your relationship with Victoria Center. So beware. And that'll be following up, but that does not take place until the first council meeting after the AGM. Oh, and if you are interested in running for a council position, or there's someone you would like to nominate from the floor, you can do so at the AGM or send me a note beforehand, and we will have an election process. Chris Peirce has the capability of creating ballots almost on the fly, I think, and I thank him for that. And that's enough said here.
And that is what's happening next week. So we need 25 people. You know, we're more than that tonight, just on a normal rainy winter evening. So we should not have trouble getting quorum. But if you cannot come, you are allowed to contact probably me is the safest thing, and say that, you know, email me saying that you would like me to be proxy, or is anybody you want to designate who's there, but make sure that we know that so that you would count in the quorum. Zoom. So that's it for today. Is the 5th, so that means it's the 12th. On the 19th, it is the family day, BC Day, so enjoy the time with your family. And we will not be holding an Astro Cafe. And the following week, we will not be holding an Astro Cafe Why? Because we are going to get together in person at the 4 Mile Pub. Who would like to talk to that?
So just before you do that, can I just interrupt for one sec?
Yeah.
To just be certain, the announcement says this meeting, the AGM is starting at 6:45. Is that the correct time?
No, the 6:45 is when the Zoom meeting will open. The meeting will start at 7. Thank you, Jeff.
Thanks very much. I've posted the invitation in the chat box. If anybody didn't receive it, if you double click on it, you can download it onto your own computer, or you can send it to yourself.
Yeah. The 6:45 was just so that the meeting doesn't start right when the Zoom starts.
Oh, thanks for clarifying that, Randy. We did, David and I did visit the venue, the 4th Avenue Pub, or the 4th Street Pub, 4 Mile Pub, rather. David, you did some pictures. Do you want to show those?
Yep, you should be able to see them. This is an overview of the parking lot, and I'll just mention that we certainly encourage carpooling to get here. There are approximately about 70 parking spaces, but that's for the pub and the restaurant. There is some overflow spacing on the road, and then we have some extra parking overflow as well. So I don't think there'll be any problems. From what we could see, we shouldn't have any problems. The interior, this is actually where the entrance is. If you come off of the road here, you'll see the sign, and then this loops around to where the other parking spaces are. There's parking here, there's parking behind me, and parking along this wall here on the end. But the entrance is right here. It can be quite confusing, but it's this little side entrance, and that actually gets you in here. So this is the door where you enter that I just showed you. This is an area here which I thought, I mentioned this to Jeff, I thought we might be able to use for our welcome area. And then the same night, we're going to be actually sharing the restaurant with a car club, which they'll actually be in a side room here. But that side room is quite small. I think it's only good for 30 people. And here's a view looking away from this. This is that potential waiting area here, or welcome area here. There are sufficient receptacles. I've actually checked that out. We will have sound reinforcement. We have a speaker that we can use. Not exactly sure where we're going to place that, but I think we can wait till the night to do that. Also, Jeff, I checked into one piece of apparatus that we might need. The tripod that actually supports the speaker is very inexpensive. It's $5 a week to rent. So I'm going to get it anyways. Whether we leave it on the floor or raise it, it'll be up to us. It only costs us $5. So it's not a big deal.
Great. The parking lot was half full when David and I were there. So I really would encourage, if you're going to arrive early rather than trying to arrive at the last minute. I suspect the pub will account for many of the spaces, as time goes on.
Yeah, we're kind of hoping that Monday night might be a quiet night, but I think some of the hosts there were saying that it's hard to predict. It's possible that all of a sudden people want it to be pub night, so there'll be a lot of people there.
Yeah, it's quite a nice venue.
Mm-hmm. Okay, is there any questions? I don't see everybody here. Did somebody have a question?
I was just gonna say, if my memory serves me right, the very first RASC Victoria banquet that I went to in the late 90s, 97 or 98, was at the 4 Mile Pub.
Yeah, it sure looked familiar. I said that to Jeff. I said, I haven't been here for a long time, but I do remember the entrance. So you could be quite right, Chris.
Yeah.
Yeah.
Margie, did you want to say anything about the numbers at this point? We're looking for, we want to get 55 people there, and we have a cap limit of 65. That's a room cap limit. So Margie's been collating the people who've been getting back to her.
Actually, Margie, can you tell us the absolute date that you have to know by? It's on a Wednesday, right?
Yes, I don't have the invitation in front of me, but yeah.
Well, actually, Lori might know. Lori, what's the last date? I guess Lori's not there.
So we need to commit numbers in advance of the actual event.
I think the Wednesday before the actual
Wednesday
date.
before.
So it's the date is actually the 29th. So it's the Wednesday before the 29th.
No,
Yeah,
the date is the 26th. We're meeting on the 26th, so it's going to be
February.
It's the 21st of February.
That we
Thank
need to
you.
know. Good.
that we need to know. Yeah.
Yeah, that's the date we put in the note, I think. Since Kirsten authored that.
Okay.
We'll be much happier if we hear early.
Yes.
Yes.
Early is better.
So bring a friend.
Margie, you'd mentioned we're at about 43 currently. Is that
Yes.
correct?
Yes, we have 43 participants.
That's good.
So we're getting there.
Mhm.
Okay, was there any other?
Yeah, I have two additional items. As far as the SIGs are concerned, tomorrow night we have the beginner SIG, and Randy, I believe you're speaking about the moon tomorrow night.
Ooh-ha.
His favorite topic. So so beginners group, anybody who doesn't belong to that SIG, let me know. David at victoria.rasc.ca. Let me know and I'll send you a link.
And
So
specifically, it's about where the moon is. Where should you look up to find it? Especially if you it's a bit cloudy and it's not just shining in your eye. How do you know where it should be?
Great. Okay, so the only other thing is often we would have a citizen science SIG, but because we don't really have any active events, that's been canceled, so we won't have one this month. And let's see, David, there is an astrophoto one on the 4th Wednesday, right? David, are you there?
Yes, sir.
I believe so,
Correct.
but I think Brock is hosting.
You're correct, and Brock is hosting.
Okay.
I might be able to attend. I just can't definitively say I will.
Right.
So
yeah, lots of interesting stuff to talk about. I can maybe even recap the discussion that we had in the makers group about the new platforms, like the new compute platforms other than Windows based ones. So we had a good chat about that. So yeah, we can certainly chat about that and anything else. Maybe we might even have some more pictures. So the very last thing I wanted to talk about, I've been against my better judgment. I've tried to go digital with so many things in terms of documentation and literature. I bought 2 books recently. So I just want to show you this. I don't know. I'm bowing to peer pressure for having books, I guess. So this is one which I got and I really like, and I think I will probably look at this one maybe during the astrophoto SIG, because this is actually quite a nice atlas. The thing that differentiates this is that we have star charts and we have actually quite large thumbnails of each of the objects. So there's 50 star charts in the thing, and it's very nicely reproduced. So I really like this. And something dear to your heart, Randy, coming up is yet another Atlas of the Moon.
Oh, I have that one.
Yeah, it's the 21st one. Now this is quite different from the Ruko one. The Ruko is kind of like drawings, but these are real. I believe these are real photographs actually.
Mhm.
So it's quite nice. So I'll have that available tomorrow night if you want to point out certain things in it during your talk or whatever. If we just want to chat about it at the
And
beginners group.
Chuck Wood is one of the big selenophiles out there.
Yeah.
I don't know Collins, but Chuck Wood is he's the one that set the Lunar 100.
Anyways, very nice book. Both are really, really good books. Okay, that's all I have.
Thank you, David.
Jeff, I just want to go continuing on. So we have the AGM, Family Day, Social. Then on the 4th of March, which is the next Astro Cafe, it's a month before the eclipse, and I want to focus on eclipse matters again. So where people are going, public outreach, viewing techniques, anything eclipse is the goal for March 4th, okay? I mean, you can present something else also, but that's a good time to really focus in on what's going to be happening the following month.
Yeah, I think the main thing now at this point is make sure you have, if you're imaging, make sure you have your filters ready and maybe take a spare and make sure you have glasses available. I would imagine some filters are going to get hard to get now. They may almost be too late.
Super. And do we have availability of glasses?
Yeah, I believe Randy has some, and I think Lori is nodding her head. So there's some up at the center of the universe.
You just have to email either Randy or I. And I've already had 3 or 4 people that have said, I want so many. And so we'll be able to give out little packages to people that are going in various places. So make sure that you've got some there.
Okay, thanks, Lori.
Good idea.
Chris Gaynor, you're there in the.
He's here in person.
Yes.
Chris,
And I've actually been in town all day, and I didn't see your email until I was actually sitting here. So I really don't have anything to report on JWST or anything like that. There are things happening, but
okay, well, maybe in a future cafe.
Yes.
I noticed an article in Nature that suggested that there was some imaging recently of some nearby spiral galaxies that sounded pretty neat.
Yeah.
But anyway, we can perhaps catch up with that later.
I think Margie had her hand up.
Oh, thanks.
Oh.
Yeah, go for it, Margie.
I have 2 questions. I don't know who the lovely lady in red is sitting between Randy and Alex, but I would like to.
My mother-in-law. One of my fans.
Oh, right. All right.
Thank you, Margie.
And the other question I would like to know is, I don't know Stephen's last name, but Stephen has on his rectangle a painting. So someone painted Stephen, and I would like to know who that is, if Stephen can tell us.
He's
Yeah, sorry, just getting unmuted there. I have to confess that it's an app. You can buy it for about $10 on the iPhone, and there you go.
Also
And my
possible.
secret's out.
Also possible on Photoshop.
Does it look like you?
It's the next step, Margie. Malcolm Scrimger had sent a note to everybody at the RASC address talking about a report in Scitech Daily that came out regarding Perseverance on Mars. As you remember, Perseverance was set up, was sent there a couple of years ago. You probably know it from the helicopter that just stopped flying, and the names escapes me. Ingenuity, yeah. Anyway, they had gone to the Jezero crater because they thought they saw what looked like a delta of previous water coming down, and they've just the report was just that ground penetrating radar had confirmed that there's sedimentary layers. So it looks like they've confirmed that that was in fact a delta where there was water flowing, and that's what it had looked like it was. But with that confirmation, they're even more excited to get the samples that are going to be coming back from Perseverance. Is there anything else that anybody wants to talk to? Any other comments or thoughts? Okay. That being the case, then I think I'll wish everybody a happy February, and we'll get together. Well, I guess we'll get together at the AGM next week. So take care.
Bye-bye, everybody.
Goodbye.
Bye.
Thank you, Jeff.